Hi children, today I am going to meet you from the second video of graphs and networks. First subtheory is adjacency matrix. The adjacency matrix is used to describe the number of edges connected between two vertices. The diagram shown over here can be represented by a matrix format that is called the adjacency matrix. Let's try to understand the special features or special facts we need to consider when you draw an adjacency matrix. From this diagram you can understand that there is only one path from A to B. Therefore, the adjacency matrix from A to B turn up into 1. As well as you can mark from B to A also as 1. Just concentrate on the fact from B to B. B to B there is no path. Therefore, the number of paths from B to B becomes 0. If you consider the path between C to F, there are no paths between C to F. Therefore, C to F or F to C turn up into 0. Now consider the path from C to B. C to B or B to C, there are two paths and both paths are unidirectional. As a result, B to E or E to B turn up into 2. Another important point is loop appear at vertex F. Usually we consider loop as a bidirectional path. As a result, F to F turn up into 2. This is the final output or final adjacency matrix respected to the given diagram. Distance matrix. What do you mean by a distance matrix? A distance matrix is a matrix which represents the weight of edges between arcs. This is one example for a distance matrix. To draw a distance matrix, initially we have to mark the vertices as shown in the diagram. What are the key points when we mark a distance matrix? First, consider the point from A to A. We can understand that A to A there are no paths. As a result, we have to mark a dash over there. The simple theorem you have to understand is if you put it as 0, that indicates that distance is 0. But the actual situation is there is no path from A to A. Therefore, you have to mark it as a dash, not as a 0. Next point you have to consider is A to B and B to A. A to B and B to A is unidirectional. Therefore, the distance from A to B or B to A you can mark it as 70. Next important point is loop E. From F to F, though it's bidirectional, both directions having the same length. As a result, the weight from E to E turn up into 50. This is the final output of the distance matrix for the given diagram. See whether can you understand the outputs of this distance matrix. This is another special case. How to draw a distance matrix for a directed graph. Now, let's try to understand what are the special features we have to consider when you mark a distance matrix for a directed graph. Let's try to consider the fact from S to R. S to R and R to S both become 4. The reason is that there is no specific direction mentioned over there. That means if you travel from S to R or R to S, you have to pass a length of unit 4. Next fact is from U to V and V to U. You can understand if you travel from U to V, you have to pass a length of 6 units, but if you travel from V to U, you have to pass another route which has a length of 7. Therefore, u to v turn up into 6 and v to u turn up into 7. Now consider the route from w to v. We can travel only from w to v, therefore the length from w to v is 9. But there is no direct route from v to w. As a result, v to w turn up into a dash. Means remember that it's not 0, it should be a dash because there is no path from v to w. This is the final output of the distance matrix for the given diagram. See whether can you understand this distance matrix.